So our first example is named Olympus Gas Well. These are chapters 2 to 5 in the manual. So this Olympus Gas Well is the water cut of this gas well is high, and it has been given from production. We know the water analysis that was obtained at the separator. We have been given gas analysis also at the separator. And we want to know if we are going to produce a scale from the reservoir through the well across the flow line into the facilities. Okay, so we will learn how to enter a water analysis. We will learn how to enter a gas analysis. Then we will saturate these fluids at reservoir conditions, and then we'll analyze the results, either running a scale scenario and a contour plot, and then we will interpret our results. Okay, so the first thing we are going to do is to enter our brine analysis. So let me go back to the software, and let me close this documents 2 and documents 3 from the navigator panel. Okay, and let me see one thing here. Something happened to my units, to my objects. Okay, so please, what we're going to do first is click on this ScaleChem Basics, and now you'll see that in your Actions panel, there are around more than 10, I think it's 13 total icons, and probably your icons look more like this, large icons. So I just changed mine. Probably you see these icons in your screen, okay? And what we are going
to sort of lost my icons when I clicked on the ScaleChem Basics icon. The actions, there's nothing in my actions panel at the moment.
Yeah, so maybe what we can do is go to calculations, ScaleChem, yep, and add
a scenario.
Yeah, let's do a scenario, just so that will bring everything for you.
Yeah, that's done it.
Okay. Yes, it just happened to me as well. That's weird. Okay, so you probably see these icons, and I want to talk a little bit about this. So personally, I don't like the icons. I like to see the list. So I will click in any white area in this Actions pane, and I'll right click on it and see the list. Okay. So you'll see, depending upon the license that you have, if you have only ScaleChem, you will see all the icons from brine analysis down to all of these icons. You will see brine analysis, oil analysis, gas analysis, saturator, scale scenario, contour, water, mixing water, and facilities. If you have the stream analyzer and ScaleChem, so you will see stream, add a mixer, and add a water analysis with all of these other ones that you see down here. And if you have the 3 components, corrosion, stream analyzer, and ScaleChem, you will see all of these icons. Okay, you have access to all of these calculations. Okay, so don't worry if you don't see specific icons. Maybe it's due to the license. If you have the training license, then you will be able to see all of the icons. Okay, so now let's identify the brine analysis icon and double click on it, and that will bring the brine analysis to the navigator panel. Okay, and in here, by default, the name is brine. but I don't want to name it brine. I want to name it Olympus brine because it's the brine that I am producing from this Olympus gas well. And I will always save. I like to save because I don't want to lose any of the work that we have done so far. So once you bring the Olympus brine here to the right, you'll see that you have a new screen here where you will enter your data. There is a data entry, and there is another tab here that is a reconcile. Okay, and this data entry and this reconcile are under this design tab, and then to analyze results, we go to the report tab. For the water analysis, notice that the thermodynamic framework MSc SRK has been selected. That's what we wanted. And also the naming of these components are in the formula form. So if you like to see sodium +1, potassium +1, that's an option. But if you prefer the naming, you can go to the names manager where it says sodium chloride and salt and click on it. And you'll see here that you have the option to display the name. And for example, if you want to see the changes right away, so you click apply. And you'll see now all the namings have changed to this display name option. I personally like the formula name, it's just shorter. And also we have the OLI name tag. And this one is whenever you're using coding or you're creating new species and anything that is internal to the software, these are the names that we use internally at OLI. So really you will not need to use this OLI name tag. You can either go with display name or formula. For formula, I think I will use formula for this training. So just click formula and apply, and that will be this is how I am going to use the names today. But again, I just show you that you have the option to change if you are more comfortable with the other naming. So in here, we are going to start entering the water analysis. So the water analysis was given to us, and in here, every time that you receive a water analysis, they will give to you cations, anions, and neutrals. So we will start entering the cations. For sodium +1, we will enter 36,000. For potassium +1, potassium ion is 300, calcium ion is 600 milligrams per liter. The magnesium +2 is 150 milligrams per liter. Strontium is 80. Barium is 5, and we don't have, or iron was not reported in this brine analysis. Then we have the anions. So we have chloride, 57,000. We have sulfates, 250. We have 600 of bicarbonate, and bisulfide has not been reported, and acetate ion was not reported. For the neutral, so anything that is a molecule but still in the it dissolved in the brine. So we don't have CO2, we don't have H2S, but silica was reported as SiO2, silicon dioxide, and that was 15 milligrams per liter. Okay, so this is the composition of the brine that was measured at was obtained from the separator. Okay, now I want to talk about what the software is doing here at the interface, at the user interface. We haven't calculated anything, but as we were entering the data, notice to your right in the summary table that the software was calculating your cation charge. It was calculating the anion charge, and it calculated an imbalance. There was a negative imbalance, okay? And in this case, that means that if we are having a negative imbalance, is because there are more anions than cations. And the amount of sodium plus, the software has selected sodium plus, to make this solution neutral is 116 milligrams per liter of sodium plus or sodium ion. Now, why is the software selecting sodium ion as the ion to complete the electroneutrality of the solution? It's because the balance option, we have selected the dominant ion type balance option. If you click on the drop-down arrow here, you'll see that there are different ways of balancing the charges of this water. The dominant ion means if I need a cation, the software goes and analyzes and sees which is the one that has the highest number. So that's the dominant ion, and then it will select that ion to do the electroneutrality. If this water was, it had a positive imbalance, then the dominant ion would have been chloride. Okay. Now you have another option, you have chloride cations. So we could have selected that the software keeps the same ratios of these cations, and it changes the amount of the cations, but it keeps the same ratios. So you'll see the changes here to the right. Or you could have done another makeup ion. Maybe you don't want sodium, maybe you want to select potassium. So you can do that. The software in this case, immediately, rather than having 300 milligrams per liter of potassium, increases it to 497 to reach electron neutrality. But I'm going to select the dominant ion option so that we all of us have the sodium as the one that has made the balance. And you'll see here that now you have 116 more milligrams of that sodium ion to reach electron neutrality. So once we are sure and we understand what's happening here, this is a very important step because you cannot simply enter the data. You need to understand if you are really needing, like maybe the software says that you have to add 2,000 milligrams of sodium plus 1. And maybe that's a red flag right there. You should go back to the lab and make sure that they are giving you a representative water analysis. Because an imbalance of 2,000, 3,000 probably is an error that it's going to introduce an error that is not going to give you a very good simulation result.
Diana, quick question.
Sure.
Is there a percentage cutoff for that cation anion imbalance that should be a red flag? And if that's the case, does OLI point out the percentage?
I want to say yes, but that is in the stream analyzer. I know that there is a table. I don't know if in here it will tell you in the ScaleChem. I don't know, to be honest. But I know in the stream analyzer it will tell you how much the difference is. It will tell you it's 5%, 10%. Let me just write that question and I'll find out if we provide that number, and I'll show you next class or maybe in the next hour where you can find that information, because I know Stream Analyzer does it.
Okay, thanks, Diana.
Percentage. But yeah, my main point here is just make sure that you don't see a significant change in the final constant disbalance column, because that will introduce error to your calculation. Okay. So the next step in this brine analysis is to go to the reconcile option. Okay. And in this reconcile option, there are several things that we need to do here. And the first thing is, you'll see, and this is a little small, let me just increase it. You'll see that there is a column where it says measure. Okay, so for that measured column, if in your water analysis you were given measured properties such as pH, alkalinity, and I don't know, in this case, electrical conductivity, density, etc., you can enter it here. Okay, so I know these were the measured properties of this specific brine analysis. So we are going to enter those values here. Okay, so we will enter that the pH, measured pH, was 7.67. My alkalinity as milligrams of bicarbonate per liter was 600. The density was 1.064, and for the total dissolved solids, 96 to 80. Okay, and those were my measured values. So that's the first thing we do here in this reconcile. If you have these values, you need to enter them. Now, this is an important one as well. At which temperature and pressure were the measured properties measured? So was it at 25 degrees C and 1 atmosphere? Was it at 30? Was it at 40? This is important. It will not, if the temperature changes are not that big, probably it will not be a problem. But if, let's say, it was 60 or 70, maybe you need to find out what were the conditions. So it's important to know the measured conditions of these properties. The second option, or the second important thing that we need to do here, is to tell the software which options we will use to calculate the brine properties. Okay, but for this example, just for demonstration purposes, I'm going to use the default option, which is the concentration data only. Okay, so with this concentration data only, the software will use all of this information we enter here to calculate the properties of this water. Okay, so, and then what we're going to do after the calculation is done is to compare if those calculated properties are more or less close to the measured properties. Okay, so that's the first option. So we can go ahead and calculate. The button is green, meaning that we are not missing any type of relevant information for the calculation. And once the calculation is done, then we can analyze the information. So there are 3 places. I see 3 places where you can analyze results here. First one, you'll see here in the calculated table, in the calculated column, you can compare now pH. So the measured pH was 7.67. The calculated pH, only using the ions in solution, is 7.5. So the calculated pH is about 0.15 units below the measured value. So then you will ask the question here, do I need that this water exactly matches my measured value? And if I wanted to match my value, then the software will either add chlorhydric acid or sodium hydroxide to make sure that pH is matched. Same for alkalinity. So in this case, the alkalinity value is around 20 milligrams less than what it was measured. And again, you have the option to match this value. So the software can add CO2, inorganic carbon, to the solution in order to match this 600 milligrams of bicarbonate per liter. And you also see that the density is not that bad, the value, the electrical conductivity, and this total dissolved solids, it says that the calculation was not enabled. So when you see this type of values here, like Na, that means that we need to make sure to enable this calculation. It was not enabled because when we add more properties to be calculated, then the calculation time or computation time it gets slower. So what we need to do, if you want to see the total dissolved solids, you go to this icon here, the last icon in the toolbars, that is called calculation options, and you click on it. And then you'll see that there are several options here for the properties. The heat capacity, for example, is not enabled, but we can calculate it. Gibbs free energy, entropy, and you'll see down here the total dissolved solids was not enabled. So we click on that total dissolved solids and then click OK. So because we enable it after this calculation was done, we need to recalculate to see that TDS value. So if you just please go ahead and calculate, and that will give us the TDS value. So now the question here is, do you think that this is a good representation of the solution? Are you okay with these calculated values that the software is giving you for pH, for alkalinity, etc.? So we have the options to match the pH and the alkalinity values, and those are the other options that you see here. So if you want to match both pH and alkalinity, you can select that option. If you want to only match the measured pH, you can do that. And we have also added this option here because the total alkalinity is in some cases is different than the total inorganic carbon alkalinity. So you can also enter match these three values. But for training purposes, and I will also do some calculations in the future having some of these options used so you can see what the software is doing. But for training calculations, we are going to say, this is okay, it's not that far, we're good, we can move on. So this is a good representation of my brine, and we can go to the next calculation. One last thing I want to talk about this brine is if you go to the report, you'll see different tables here, 4 different tables. And in here, basically, the stream properties is summarizing the conditions at which you did the calculation. You have your phase properties, all properties of the aqueous phase. This will be our favorite table of the training, the pre and post scaling tendency values. And I just noticed that it's 9:54 in my side. So I think that maybe after the break, I can continue explaining this table and then go to my next analysis that will be a gas analysis. Okay, so I'll just go ahead. Let's go ahead and take a 6-minute break, and we will start at the top of the hour with this analyzing the report of the brine analysis. And I check the chat as well and see if there are questions there.